What if the Big Bang wasn't the beginning, but a rebirth? What if our entire 93 billion light-year observable universe is just a single object inside a much larger, older cosmos? This isn't science fiction, it's actually a possibility being explored by theoretical physicists who are challenging our most fundamental understanding of existence. The clues might be hidden in plain sight, in the behavior of black holes and the baffling arrangement of the most distant galaxies spotted by the JWST. Let's explore this mind-bending possibility together. The standard Big Bang model. So, how did we arrive at our current picture of the universe? The story most of us know is the standard model of cosmology, first mathematically conceptualized by the Belgian priest and physicist Georges Lemaitre in 1927. It states that our universe exploded into being 13.8 billion years ago from a point of extreme density. From this intensely hot state, space itself began to expand. Over billions of years, gravity sculpted this expanding cosmos, pulling matter together to form the vast, web-like structure of galaxies we observe today. This model is incredibly successful. It explains the faint afterglow of the Big Bang, the cosmic microwave background, and it accounts for the accelerating expansion of the universe. This acceleration, confirmed in 1998, is often attributed to dark energy, which makes up about 68% of the universe. When combined with dark matter, at around 27%, it appears 95% of our cosmos is made of stuff we can't see or understand. This means that all the stars, planets, and galaxies we can observe make up a mere 5% of reality. The bottom line is the standard model, for all its successes, leaves us with the biggest questions in science completely unanswered. The black hole universe theory. What if there's a more elegant explanation, one that doesn't require inventing new particles or mysterious forces? A radical alternative championed by physicist Nikodem Poplawski proposes that our universe was born inside a black hole within a much larger parent universe. This idea flips our perspective on cosmic origins entirely. Instead of a singularity appearing from nothing, the theory suggests a physical process, the gravitational collapse of matter in a parent universe. Think of it like a star many times the mass of our sun collapsing to form a black hole, but on a cosmic scale. In this model, what we perceive as the Big Bang was actually the moment our universe formed inside that parent black hole. This framework elegantly resolves the issue of what came before the Big Bang, as the parent universe provides a clear preceding state. It suggests a cycle of birth and rebirth, where universes beget new universes, stretching back into an unknown past and forward into an infinite future. Quantum mechanics and degeneracy pressure. Here's where things get really interesting, and it hinges on a core principle of quantum mechanics. Have you ever wondered what stops a dead star from collapsing forever? The answer lies in a rule established by the brilliant Austrian physicist Wolfgang Pauli. His exclusion principle states that identical particles, like electrons, cannot occupy the exact same quantum state at the same time. When gravity tries to crush matter into an incredibly small space, this principle creates a powerful outward push known as degeneracy pressure. The more you squeeze, the harder the particles push back. This is the force that supports white dwarfs against collapse, where matter is packed to a density of over 1 million kilograms per cubic centimeter. In even more extreme objects like neutron stars, the pressure is even greater, holding up against densities of over 100 trillion kilograms per cubic centimeter. This pressure is fundamentally different from thermal pressure, which supports a star like our Sun, as it doesn't depend on temperature at all. Proponents of the black hole universe theory argue that this same quantum pressure could operate on the scale of an entire collapsing universe, offering a mechanism to avoid the infinite singularity. The bounce mechanism. So, if a universe collapses, what happens when this quantum pressure kicks in? Instead of crushing down to an infinite point, a singularity where physics breaks down, the collapse could halt and rebound. This is the Big Bounce, a concept heavily explored in loop quantum cosmology by physicists like Martin Bojewald. In this scenario, as the matter of a parent universe collapses, it approaches the theoretical maximum density allowed by physics, known as the Planck density, which is about 5.1 times 10 to the 96 kilograms per cubic meter. At this point, quantum gravity effects become so powerful, they overwhelm everything else. This force stops the collapse in its tracks and triggers a massive, explosive rebound. This rebound event would be incredibly brief but unfathomably violent, essentially resetting the cosmic clock for the new universe. To any observer inside this newly expanding region, that rebound would look and feel exactly like a Big Bang, while potentially preserving information from the prior cosmic cycle. This model is powerful because it replaces the mathematical fantasy of a singularity with a continuous physical process. Evidence from early galaxies. This might all sound like fascinating speculation, but where's the evidence? It might be hiding in the deepest images of our universe captured by the James Webb Space Telescope. According to the standard model, galaxies should build up gradually. Yet JWST is finding galaxies that are bafflingly massive and mature. For instance, the GLASS JWST Early Release Science Program, involving astronomers like Rohan Naidu, has identified galaxies like GLASS Z12 at a redshift of 12, meaning we see them as they were just 350 million years after the Big Bang. These galaxies are already a billion times the mass of our Sun, far larger than our models predicted was possible so early on. Furthermore, these ancient galaxies appear to host supermassive black holes that are millions of times the Sun's mass, a phenomenon that standard models struggle to explain so soon after the Big Bang. The Big Bounce model, however, offers a potential explanation, suggesting these black holes could be relics that survived from the previous cosmic era, acting as gravitational seeds. Galaxy rotation mystery. Now for another cosmic puzzle that might point to the same conclusion. In a random and uniform universe, you would expect galaxies to be spinning in all different directions, with a roughly 50-50 split between clockwise and counterclockwise rotations. But that's not what we see. A 2020 study analyzing over 200,000 spiral galaxies led by computational astronomer Lior Shamir found a significant imbalance. There appears to be a preferred direction of spin, an alignment across vast stretches of the cosmos. The statistical probability of this asymmetry happening by chance is less than 1 in a billion. This unexpected alignment, observed across a scale of billions of light-years, implies that processes during the formation of the universe were not as random as we thought. This large-scale pattern challenges the long-held assumption that the universe is the same in all directions, a principle that underpins virtually all of our cosmological calculations. One of the explanations for this strange alignment is that our universe could have inherited the rotation of the object it was born from, like a massive spinning black hole in a parent universe. Schwarzschild cosmology. So this idea of a universe inside a black hole isn't entirely new. It actually falls under a concept known as Schwarzschild cosmology. The name comes from Carl Schwarzschild, who, back in 1916, found the first exact solution to Einstein's field equations describing the space-time around a spherical mass, what we now call a black hole. The model suggests that, well, the observable universe is the interior of a black hole existing within a larger parent universe. From our perspective, the Big Bang was the formation of this black hole, and from the outside, our entire cosmos would just look like a regular black hole. The size of this black hole's event horizon is defined by the Schwarzschild radius, and for a universe with the mass of ours, this radius is, interestingly, remarkably close to the radius of our observable universe. Mathematically, the singularity at the beginning of our universe is similar to the singularity at the center of a Schwarzschild black hole. The edge of our observable universe, which is a sphere with a diameter of 93 billion light-years, acts much like a black hole's event horizon, a boundary from which light cannot escape to an outside observer. Black holes as universe creators. Let's take this idea to its logical conclusion. If our universe was born inside a black hole, what does that imply about the estimated 100 million stellar mass black holes in our own galaxy? It suggests that each and every one could be a gateway, a seed for a new baby universe. This paints, honestly, a picture of a vast cosmic ecosystem, a multiverse where universes are constantly being born. This concept, known as cosmic natural selection and explored by physicist Lee Smolin, could even offer an explanation for the fine-tuning problem, the mystery of why the fundamental constants of physics are so perfectly set for life. If universes are constantly being created, then perhaps only those whose physical laws allow for the creation of stable black holes can themselves reproduce, leading to a multiverse dominated by life-friendly universes. This theory proposes that our universe is so adept at creating black holes precisely because it was born from one, continuing an unending cosmic lineage. Torsion and space-time twisting. For a universe to bounce instead of collapsing into a singularity, you need a powerful repulsive force at extreme densities. One candidate for this force comes from an extension of general relativity known as Einstein-Cartan theory. The mathematics behind this were developed in the 1920s by the brilliant French mathematician Élie Cartan. This theory incorporates a property of space-time called torsion, which accounts for the intrinsic spin of fundamental particles. This spin is a fundamental quantum property like mass or charge that gives particles an inherent angular momentum. In standard general relativity, space-time can bend, but it cannot twist, making the inclusion of torsion a significant modification needed for this theory to work. According to physicists like Nikodem Poplawski, at the densities found inside a black hole, the interaction between torsion and the spin of particles would create a powerful repulsive force. This torsion-induced bounce would be the mechanism that creates a new universe inside every black hole, making them not just cosmic destroyers but creators. Cosmic anisotropy. The evidence for a preferred direction in galaxy spins points to a concept called cosmic anisotropy, the idea that the universe is not the same in all directions. This directly challenges the cosmological principle, a foundational assumption in modern cosmology. This isn't just about galaxy spins. Anomalies in the cosmic microwave background radiation, first noted in data from the WMAP satellite and later confirmed by the Planck satellite, also suggest a large-scale alignment. Physicist João Magueijo famously dubbed this the axis of evil because it aligned with our solar system's plane, a result so strange it had to be a mistake, except it kept showing up with a statistical probability of being random at less than 0.1%. These anomalies, once dismissed as statistical flukes or errors in measurement, are now forcing a re-evaluation of fundamental assumptions, which is exactly how science progresses. If our universe was born inside a spinning black hole, it would have inherited that axis of rotation, creating a preferred direction that could influence the formation and spin of galaxies. From the impossible galaxies seen by JWST to the mysterious alignment of galactic spins, we are faced with observations that don't quite fit our standard story of the cosmos. The idea that our universe is inside a black hole, born from a cosmic bounce, offers a potential framework to explain these anomalies without inventing new physics. It suggests we might be part of an endless cycle of creation. What do you think? Are we living inside a black hole? Let me know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Future Facts. In 2017, Oumuamua became the first confirmed interstellar visitor to our solar system, sparking debates about its true nature. Now, with the recent discovery of 3I/Atlas in 2025, scientists are comparing these mysterious objects and finding that Oumuamua's bizarre properties look increasingly artificial. While most interstellar objects behave predictably, Oumuamua's strange acceleration, unusual shape and reflective surface continue to defy explanation. The more we learn about typical interstellar objects, the more Oumuamua stands out as something potentially extraordinary and possibly not natural at all. The discovery of 3I/Atlas. The discovery of 3I/Atlas in January 2025 by the Asteroid Terrestrial Impact Last Alert System marked humanity's third confirmed interstellar visitor. Unlike its predecessors, 3I/Atlas immediately displayed characteristics that astronomers expected from natural interstellar objects. Dr. Robert Warwick, who also discovered Oumuamua, led the initial observations that confirmed the object's hyperbolic trajectory and interstellar origin. 3I/Atlas measures approximately 200 meters in diameter and exhibits a normal comet-like behavior with visible outgassing as it approaches the Sun. The object's spectroscopic signature matches typical solar system comets, containing water ice, carbon monoxide, and dust particles. Most importantly, 3I/Atlas follows predictable orbital mechanics without any unexplained acceleration. Its discovery comes at a crucial time when scientists are still debating the nature of Oumuamua, providing a control group for comparison. The stark differences between these interstellar visitors have only deepened the mystery surrounding Oumuamua's true identity and origin, making the earlier object appear increasingly anomalous in comparison. The Oumuamua discovery. On October 19, 2017, the Pan-STARRS 1 telescope in Hawaii detected a fast-moving object that would revolutionize our understanding of interstellar visitors. Initially designated A2017U1, the object's trajectory calculations revealed it was traveling too fast to be gravitationally bound to our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast confirmed the object's interstellar origin within days of discovery. Scientists quickly realized they were observing humanity's first confirmed visitor from another star system, prompting an immediate naming ceremony. The object received the Hawaiian name Oumuamua, meaning messenger from afar arriving first, reflecting its historic significance. However, classification proved challenging. Oumuamua showed no visible coma or tail typically associated with comets, leading to its initial designation as an asteroid. Yet, its trajectory and composition didn't match typical asteroids either. Dr. Marco Michelli from the European Space Agency noted that Oumuamua represented an entirely new category of celestial object, requiring unprecedented international cooperation to study before it disappeared forever into deep space. Oumuamua's strange properties. Oumuamua's physical characteristics immediately set it apart from any known solar system object. Light curve analysis conducted by Dr. Karen Meach from the University of Hawaii revealed dramatic brightness variations of a 10-to-1 ratio, suggesting an extremely elongated shape unlike any asteroid or comet previously observed. The object appeared to be 400 meters long and only 40 meters wide, giving it a cigar-like appearance that tumbled end over end every 7.3 hours. Dr. Wes Fraser from Queen's University Belfast noted that such extreme elongation would be impossible for a natural object to maintain over interstellar distances without being torn apart by gravitational forces. Oumuamua's surface composition also proved puzzling. Spectroscopic observations showed a reddish coloration consistent with organic compounds, yet the object reflected sunlight far more efficiently than expected. The combination of unusual shape, high reflectivity, and lack of detectable water ice or other volatile compounds created a profile that matched no known category of cosmic debris, leading to intense speculation about its true nature and possible artificial origin. The acceleration mystery. The most perplexing aspect of Oumuamua really emerged when Dr. Marco Michelli analyzed precise tracking data from, multiple observatories. Rather than following a predictable gravitational trajectory, Oumuamua actually exhibited unexplained acceleration away from the Sun beginning in June 2017. This non-gravitational acceleration measured approximately 2.5 times 10 to the -4th meters per second squared. It's small but statistically significant and, consistent across multiple observations. Typically, such acceleration results from outgassing as comets approach the Sun, creating a sort of rocket effect that pushes the object forward. However, Spitzer Space Telescope observations led by Dr. Davide Farnokia from NASA JPL found no evidence of dust particles, water vapor, or any other materials being ejected from Oumuamua's surface. The object appeared completely inert, showing no coma, tail, or detectable outgassing that could explain its acceleration. This combination of measurable thrust without a visible propulsion mechanism created an unprecedented puzzle in solar system dynamics, forcing scientists to consider explanations that challenge conventional understanding of how celestial objects behave in space, including, even the possibility of artificial technology. Scientific investigations. So, following Oumuamua's departure, scientists launched these intensive investigations to understand its, anomalous properties. Dr. Alan Jackson from Arizona State University led studies using Hubble Space Telescope data to refine measurements of the object's acceleration and rotation. The Spitzer Space Telescope observations, coordinated by Dr. Davide Farnokia, proved crucial in ruling out traditional comet-like outgassing as the source of Oumuamua's acceleration. These infrared observations detected no thermal emission from dust particles that would accompany normal cometary activity. Radio telescope arrays led by Breakthrough Listen conducted extensive searches for artificial signals but, honestly, found no evidence of technological emissions. Dr. Abraham Loeb from Harvard University argued that the lack of detectable outgassing, combined with the object's high reflectivity, suggested Oumuamua might have an artificial origin. The reflective surface discovery became particularly significant when scientists calculated that Oumuamua reflected 10 times more light than typical asteroids, indicating either an unusual composition or possibly an artificially manufactured surface designed for maximum light reflection, kinda like a solar sail technology. The alien hypothesis. Dr. Abraham Loeb, chair of Harvard's astronomy department, proposed the most controversial explanation for Oumuamua's behavior. It could be an artificial light sail created by an extraterrestrial civilization. In his 2021 book Extraterrestrial, Loeb argued that Oumuamua's combination of extreme elongation, high reflectivity, and unexplained acceleration matched theoretical designs for interstellar probes powered by starlight. The light sail hypothesis explained how Oumuamua could accelerate without detectable outgassing. Radiation pressure from sunlight could push against a thin, highly reflective surface, creating the observed non-gravitational forces. Dr. Loeb calculated that a sail just millimeters thick, but hundreds of meters wide, could generate the measured acceleration while remaining stable during its tumbling motion. He noted that such technology is already being developed by human civilization, making it, plausible that advanced aliens might deploy similar reconnaissance probes throughout the galaxy. The hypothesis gained attention because it provided a unified explanation for all of Oumuamua's anomalous properties, though it required accepting the extraordinary possibility that we had detected our first piece of alien technology visiting our solar system. The dark comet theory. So, the dark comet theory was put forward by Dr. Darryl Seligman from the University of Chicago and Dr. Gregory Laughlin from Yale University as a natural alternative to explain Oumuamua's mysterious acceleration. Their dark comet theory suggests that the object could actually be made up mostly of solid hydrogen, which would sublimate or turn directly from solid to gas when heated by the sun. Now, unlike water ice or other volatile substances, hydrogen gas is, basically invisible to most telescopes, and that could explain why no outgassing was detected, even though the object was speeding up. Dr. Seligman worked out that hydrogen ice could stay stable during its long interstellar journey through the cold vacuum of space, so the object's structure could be preserved over millions of years. Then, as Oumuamua got closer to the sun, the surface would heat up, causing hydrogen to sublimate and create these invisible jets of gas. Jets that could actually cause the weird acceleration scientists observed. The theory also helped explain the object's unusual density and structural stability. Hydrogen ice is light enough to let Oumuamua keep its elongated shape without collapsing under its own gravity. The ongoing debate. So the debate is still going strong. Even though the dark comet theory has a lot of scientific appeal, Dr. Abraham Loeb remains pretty skeptical of purely natural explanations for Oumuamua's behavior. In interviews from 2023, Loeb argued that the hydrogen ice hypothesis faces some significant problems, like, for example, the extreme rarity of hydrogen-rich objects in our solar system, and the really precise timing needed for such an object to visit Earth. He also pointed out that hydrogen ice would just keep sublimating during interstellar travel, which makes it pretty unlikely that enough material could actually survive the million-year journey from the nearest star systems. On the other hand, Dr. Seligman countered these objections with updated models, showing that subsurface hydrogen could stay protected beneath a thin crust of heavier materials. But, the scientific community is still deeply divided on Oumuamua's true nature. Dr. Jane Green from NASA Ames noted that both explanations require accepting either extremely rare natural phenomena or, honestly, unprecedented artificial technology. This whole debate really highlights some fundamental questions about scientific methodology, like do extraordinary claims require extraordinary evidence, and how should scientists approach phenomena that just don't fit into existing paradigms? It's definitely challenging our understanding of what's possible in the universe. Project Lyra mission concept. So, recognizing that ground-based observations just can't resolve the mystery of Oumuamua, Dr. Andreas Hein from the University of Luxembourg proposed something pretty ambitious, Project Lyra. It's a mission designed to intercept and study the object before it disappears forever. The mission concept, which was developed with collaboration from ESA and NASA, would launch a high-speed probe that's actually capable of catching up to Oumuamua, even with its velocity of 26 kilometers per second relative to Earth. Dr. Adam Hibbard from the Initiative for Interstellar Studies calculated that such a mission would need some really advanced propulsion technology, including ion drives and gravity assists from multiple planets, to reach the necessary speed. The probe would be equipped with high-resolution cameras, spectrometers, and particle detectors, so it could definitively determine Oumuamua's composition and structure. There are launch windows for Project Lyra until 2029, and after that, the object will just be too distant for any foreseeable technology to reach. Dr. Hine emphasized that this is basically humanity's only opportunity to directly examine our first confirmed interstellar visitor and maybe answer one of the most important questions in astronomy. Are we looking at natural phenomena, or could this actually be alien technology? The Future Hunt. Looking to the future, the Vera C. Rubin Observatory, which will begin operations in 2025, represents our best hope for discovering and studying future interstellar visitors. Dr. Lynn Jones from the University of Washington is leading efforts to optimize the observatory's legacy survey of space and time, specifically for detecting objects like Oumuamua, and with enough advance warning to allow for detailed study. Thanks to the observatory's unprecedented sensitivity and wide field of view, it should be able to detect dozens of interstellar objects every year, giving us a statistical sample to figure out whether Oumuamua is a rare anomaly or part of a larger population of unusual visitors. Dr. Robert Warwick predicts that within 5 years we'll have enough interstellar object discoveries to definitively classify Oumuamua as either natural or artificial. If most interstellar visitors behave like normal comets and asteroids, then Oumuamua's uniqueness will only strengthen arguments for its artificial nature. But if a lot of interstellar objects show unusual properties, it could point to previously unknown natural formation processes. Either way, the ongoing mystery has already transformed asteroid and comet research, pushing scientists to expand their understanding of what's possible in the universe and to get ready for unexpected discoveries. The discovery of 3I/Atlas has actually given us some crucial context, making Oumuamua seem even more anomalous. While 3I/Atlas behaves exactly the way scientists expect natural interstellar objects to behave, Oumuamua's combination of unexplained acceleration, extreme elongation and high reflectivity just keeps defying conventional explanations. Whether it turns out to be advanced alien technology or an entirely new class of natural phenomena, Oumuamua has, without a doubt, permanently changed our perspective on what could be traveling between the stars. So, which explanation do you find most convincing? Share your thoughts below. And hey, if you enjoyed this cosmic mystery, hit like, share with your fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. What if the most terrifying message from the stars wasn't a broadcast but an object? And what if that object wasn't just visiting but reporting back to something else? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object designated 3I Atlas. But as they decoded its transmissions and analyzed its impossible flight path, they confirmed a fear that humanity has held for centuries. This wasn't a random rock, it was a messenger. Let's explore this together. The impossible visitor. So, what happens when a visitor from another star system doesn't just tumble through, but navigates? When the Vera C. Rubin Observatory in Chile first flagged 3I Atlas in early 2025, it immediately defied every known classification. Unlike our previous interstellar guests, this object exhibited something that sent a chill through every Mission Control Center-controlled flight patterns. Dr. Karen Meach, a University of Hawaii astronomer renowned for her work on Oumuamua, was among the first to note that its trajectory was non-ballistic to a degree that is simply not natural. It executed deliberate, impossibly precise course corrections. Its sheer scale was staggering. It was surrounded by a massive 700,000-kilometer coma, a glowing envelope of gas and plasma nearly half the diameter of our own sun. But unlike a comet's coma, this one didn't sublimate chaotically. It pulsed, beating like a cosmic heart with powerful electromagnetic signals at a frequency of 1.42 gigahertz. The hydrogen line, a frequency famous in SETI circles, firing in a perfect rhythm once every 147 seconds. As this impossible visitor carved its way through our asteroid belt with surgical precision, one chilling question began to emerge. What if this thing wasn't exploring, but was actively reporting back? When physics stopped making sense. Here's where the story takes a sharp turn from a scientific curiosity into a genuine threat. Most objects from beyond our solar system follow chaotic trajectories, their paths dictated by gravity. But 3I Atlas demonstrated something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lascar from the Paris Observatory ran the orbital simulations backward, they discovered something statistically impossible without intelligent intervention. The path of 3I Atlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was simply breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arcseconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board, avoiding every conceivable threat with a precision that suggested either advanced, long-term planning or sophisticated real-time control. This wasn't a random space rock wandering through the cosmos, it was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. The unsettling feeling that we were dealing with something far beyond our comprehension only intensified when NASA, under the guidance of senior JWST scientists like Dr. Jane Rigby, pointed the James Webb Space Telescope toward 3I Atlas. The results that came back didn't just challenge our understanding, they completely rewrote the rulebook. The thermal readings showed a consistent, stable temperature of 120 Kelvin, with rhythmic heat emission patterns that pulsed in sync with its radio signals, a behavior that defies thermodynamics. Webb's spectrography revealed materials never before seen, including hyper-reflective compounds that returned almost 99% of the light that hit them. But the most disturbing discovery was a faint, recurring electromagnetic anomaly echoing from within. This low-bandwidth frequency at 408 MHz, repeated every 147 seconds, matching the exact signature of a known pulsar, PSRB 1919+21. The problem, as any physicist would attest, was that the object had no spinning core, and no magnetic field capable of generating such a signal. It appeared to be mimicking something it had encountered, or worse, actively communicating with something beyond our detection capabilities. 2 visitors, 1 terrifying pattern. The mystery deepened significantly when researchers cross-referenced 3I Atlas's electromagnetic signature with archived data from Oumuamua. The comparison revealed something that sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation, but active engagement. It was the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. Just when scientists believed they had mapped 3I Atlas's future trajectory, the object performed a maneuver that shattered every remaining assumption. Telescopes in Chile and Hawaii recorded a subtle but unmistakable course shift that couldn't be explained by gravity or solar wind. The object veered slightly off its projected arc, executing a 15-meter-per-second delta V that realigned its vector, bringing it 0.1 astronomical units closer to Earth's orbital plane. To mission analysts at NASA's Deep Space Network at JPL, the implications were alarming. The timing and precision of this maneuver implied conscious decision-making. The maneuver occurred precisely when the James Webb Space Telescope had achieved its optimal tracking position, suggesting the object was not only aware of our surveillance efforts, but was reacting to them. This transformed 3I Atlas from an astronomical curiosity into a potential confirmation of technologies far beyond our own. It was no longer a passive object of study, it was an active participant in a cosmic dialogue we didn't know we were having, a dialogue that was now escalating. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal: the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't arbitrary concepts. They represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. James Webb's detailed spectroscopic analysis revealed another disturbing layer to the 3I Atlas mystery. The telescope detected complex carbon molecules on the object's outer shell, specifically polycyclic aromatic hydrocarbons, which are the building blocks of prebiotic chemistry. These compounds, as astrobiologists like Carl Sagan have long theorized, are the precursors to life itself. What was alarming was the purity and organization of these molecules. Unlike the chaotic mixtures found in comets, the compounds on 3Y Atlas showed 99.9% isotopic consistency, a level of molecular organization that just doesn't occur naturally in space. The spectral lines at 3.3 micrometers, a key signature of PA8s, were honestly, unnaturally sharp and clear. Some researchers, including those at MIT under the guidance of experts like Dr. Sarah Seeger, began to theorize that 3Y Atlas might represent a seed ship, an ancient vessel designed not just to explore, but to plant the foundations of life on suitable worlds. If this theory held merit, then Earth's location along the object's trajectory might not be a coincidence at all. When Earth responded to the cosmic visitor. The connection between 3I Atlas and Earth became far more unsettling when a classified high-altitude surveillance balloon managed by the U.S. Antarctic program detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 gigahertz, sharp and centered precisely above the South Pole. Initially dismissed as interference, its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low-frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3I Atlas. The synchronization was impossible to dismiss as a coincidence. Somehow, this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The asteroid belt death run. 3I Atlas is currently navigating through the main asteroid belt, a phase that presents unprecedented risks. Unlike other objects, 3I Atlas cuts directly through the belt's core at a low 5-degree inclination, passing through a region with a particle density 50% higher than the belt's average. The object, moving at a blistering 42 kilometers per second, is surrounded by its massive 700,000-kilometer coma, creating unprecedented interactions with the billions of objects in the belt. Planetary scientists at institutions like the Southwest Research Institute are watching with bated breath. As 3I Atlas moves through this environment with its powerful electromagnetic signature, it's creating disturbances never before observed. While a direct collision remains statistically low, its gravitational and electromagnetic effects could potentially alter the trajectories of other bodies in unpredictable ways, creating a cascading effect or, more concerningly, redirecting the object itself toward Earth's orbital path. This is a cosmic gamble with planetary consequences. Rewiring our solar system's neural network. Scientists have now discovered that 3I Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic web effect. As 3I Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen telescope array show that 3I Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, a signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings. But either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The story of 3I Atlas is far from over. In fact, it may just be the beginning of a much larger, more terrifying story. The mounting evidence, the deliberate course corrections, the mathematical signals, the organic chemistry, and now a broadcast pointed toward deep space, all suggest that this object is not the main event. It is a precursor. It is an announcement that our solar system is no longer a quiet, isolated neighborhood. We may have just accidentally triggered a sequence of events that will fundamentally change humanity's place in the universe, and we are completely unprepared for what comes next. Thank you for watching Future Facts. In a groundbreaking event, the James Webb Space Telescope has captured what many call the first real image of the interstellar visitor, 3I Atlas. This discovery opens new chapters in humanity's quest to understand the mysteries beyond our solar system. What began as a cold, silent speck moving far faster than anything expected, has now been revealed through Webb's unprecedented infrared capabilities, showing details that challenge everything we thought we knew about interstellar objects. The flicker in the data. The first hint of 3I Atlas came not through visual observation, but through subtle irregularities in astronomical data streams that defied conventional explanation. Ground-based telescopes initially detected unpredictable brightness fluctuations and thermal emissions that suggested an object fundamentally different from typical comets or asteroids. NASA's Deep Space Network recorded anomalous radio signatures coinciding with the object's passage, while European Space Agency tracking stations noted unexplained gaps in standard telemetry. These data inconsistencies formed a pattern that Dr. Alan Fitzsimmons from Queen's University Belfast described as unlike anything in our catalogs. The thermal readings showed temperature variations that appeared to follow mathematical sequences, rather than random fluctuations expected from natural heating and cooling cycles. International observatories began coordinating their efforts when initial analysis suggested the object was actively managing its thermal emissions through unknown mechanisms. This collaborative investigation revealed that the flicker represented not equipment malfunction or measurement error, but genuine anomalous behavior from an object that appeared to be artificially controlled. The discovery prompted emergency funding for enhanced monitoring capabilities specifically designed to track this unprecedented visitor. 152,000 mph from the void. 3I Atlas races through space at a staggering velocity of approximately 152,000 miles per hour, relative to our solar system, far exceeding the typical speeds of natural debris ejected from stellar systems. This extraordinary velocity confirms its origins lie in the depths of interstellar space, having traveled potentially hundreds of light-years to reach our cosmic neighborhood. Dr. Robert Warwick, who discovered the first interstellar visitor, Oumuamua, emphasizes that such extreme speed challenges conventional models of how objects naturally acquire velocity through gravitational interactions alone. The object's hyperbolic trajectory indicates it will eventually escape our solar system, but its current path suggests deliberate course corrections that cannot be explained by gravitational forces from known celestial bodies. Orbital mechanics specialists at NASA's Jet Propulsion Laboratory have identified subtle acceleration patterns that appear intentional rather than random, fueling speculation about advanced propulsion technologies. Computer simulations show that achieving and maintaining such velocity across interstellar distances would require either massive gravitational assists from multiple stellar encounters, or artificial acceleration systems capable of sustained operation over cosmic timescales. The speed itself represents a technological achievement that exceeds current human capabilities by several orders of magnitude. 3 visitors, 7 years. Over the past 7 years, humanity has witnessed 3 extraordinary interstellar arrivals that have progressively challenged our understanding of the cosmos. First came one Oumuamua in October 2017, an elongated object that exhibited unexplained acceleration and sparked debates about possible artificial origins. 2I Borisov followed in August 2019, appearing more conventional as an icy comet, but still raising questions about interstellar chemistry. Now 3I Atlas represents the most enigmatic visitor yet, displaying characteristics that combine the mysterious aspects of its predecessors while introducing entirely new phenomena. Dr. Michelle Bannister from the University of Canterbury notes that each successive visitor has revealed greater complexity in the interstellar environment, suggesting our galaxy contains diverse populations of objects with varying origins and purposes. Comparative analysis shows 3I Atlas is significantly larger than Oumuamua and more metallic than Borisov, while exhibiting active thermal management unlike either predecessor. Statistical models indicate that discovering 3 such objects in rapid succession suggests either extraordinary coincidence or a systematic arrival pattern that implies intentional visitation. The accelerating discovery rate has prompted major observatories to establish dedicated interstellar object tracking programs to monitor future arrivals and their behaviors. James Webb's metallic discovery. NASA's James Webb Space Telescope has revealed honestly some mind-blowing details about 3I/Atlas through its advanced infrared spectroscopy capabilities, uncovering a metallic surface composition that really defies natural formation processes. Dr. Heidi Hamel, who serves as Webb's interdisciplinary scientist, led the spectroscopic analysis that identified titanium-aluminum alloys and other engineered materials, which are totally inconsistent with what we usually see in asteroids or comets. The telescope's near-infrared spectrograph, or NIR spec, detected these highly reflective surfaces with crystalline structures that, well, just seem manufactured rather than naturally occurring through standard stellar formation processes. Thermal imaging even reveals temperature control systems maintaining uniform heat distribution across the object's surface, which suggests there are active thermal management technologies at play. Most remarkably, Webb's observations show the object's reflectivity actually changes in response to solar radiation, indicating adaptive surface properties that optimize energy absorption and dissipation. Materials scientists analyzing the spectral data report, almost unbelievably, impossible purity levels for the detected metals, requiring advanced refining techniques that are way beyond current human capabilities. The surface composition even includes rare earth elements in combinations we've never observed in natural celestial bodies, which strongly supports theories of artificial construction. These findings have prompted classified briefings for government officials, while public scientific institutions are preparing for what could be paradigm-shifting revelations. The machine that steers itself. Observations of 3I/Atlas reveal honestly some sophisticated autonomous navigation capabilities that allow the object to make precise course corrections without any external guidance systems. Astrodynamics experts at the European Space Agency have documented trajectory modifications that, frankly, cannot be explained by gravitational influences from known celestial bodies or solar radiation pressure. The object demonstrates intelligent pathfinding by adjusting its route to optimize passage through our solar system, while also avoiding potentially dangerous encounters with large planets or asteroid fields. Dr. Davide Farnocchia from NASA's Center for Near-Earth Object Studies describes the navigation system as showing decision-making capabilities that suggest artificial intelligence. Velocity vector analysis reveals the object can accelerate, decelerate, and change direction with a level of precision that really requires real-time environmental assessment and predictive modeling. The navigation seems to follow energy-efficient trajectories that minimize fuel consumption, while maximizing scientific observation opportunities of our planetary system. Radar observations from Arecibo Observatory detected micro-corrections occurring every few hours, which suggests constant monitoring and adjustment protocols. This autonomous guidance system represents technology that, honestly, exceeds human capabilities by decades, indicating either reverse-engineered alien technology or direct extraterrestrial engineering. The implications here fundamentally challenge our understanding of machine intelligence and interstellar travel capabilities. Information blackout. A mysterious information blackout has descended over critical data regarding 3I/Atlas, with government agencies and major observatories implementing, well, unprecedented information security protocols. Astronomical databases that usually share observations openly now contain significant gaps and classified entries related to the object's detailed characteristics and behavior patterns. Dr. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics reports that, honestly, normally transparent scientific institutions have become unusually secretive about ongoing observations and analysis results. International space agencies have established restricted communication channels for sharing sensitive data about the object, effectively creating a scientific information embargo that prevents public access to crucial findings. Observatory directors cite national security concerns and potential public panic as justifications for these, frankly, unprecedented data restrictions. Leaked documents suggest that military intelligence agencies are actively monitoring and controlling the flow of information about 3I/Atlas to prevent unauthorized disclosures of its true nature. Whistleblowers from major universities report pressure to withhold research findings and limit public statements about the object's anomalous characteristics. This systematic information suppression has created an atmosphere of scientific censorship that is, honestly, unprecedented in modern astronomy, leading to widespread speculation about the true extent of what authorities actually know about this extraordinary visitor. Adaptive shielding technology. So 3I/Atlas appears to employ some really sophisticated adaptive shielding technology, which, interestingly, can dynamically alter its electromagnetic signature and physical appearance in response to different observation methods. Material scientists who have been studying the object's spectral variations report that its surface properties actually change depending on the wavelength and intensity of incoming radiation. Dr. Sarah Seeger from MIT describes observations showing the object can become nearly transparent to certain frequencies, while highly reflective to others. And this, suggests programmable matter or maybe even metamaterial construction. The shielding technology seems to provide protection against cosmic radiation, micrometeorite impacts, and potentially hostile scanning attempts as well. Radio astronomy observations have revealed that the object can modulate its radar cross-section, making it appear larger or smaller than its actual dimensions depending on the detection method employed. Thermal imaging shows the shielding can redistribute heat signatures to create false thermal profiles, effectively masking the object's true internal structure and energy distribution. Quantum physicists, meanwhile, theorize the technology might utilize field manipulation or controlled phase transitions in exotic matter to achieve these adaptive properties. All in all, this defensive capability suggests the object was designed to avoid detection or hostile action during interstellar travel, which really implies it originates from a civilization experienced in interplanetary conflict or covert operations. The Ancient Probe Network. Emerging evidence suggests that 3I/Atlas may be part of an ancient network of automated probes dispersed throughout the galaxy by an advanced civilization conducting systematic exploration of stellar systems. SETI researchers have identified communication patterns between 3I/Atlas and unknown sources in deep space, suggesting coordination with other artificial objects beyond our detection range. Dr. Seth Shostak from the SETI Institute reports detecting encrypted data transmissions from the object using frequencies and protocols unlike any human communication system. Mathematical analysis of these signals reveals complex algorithms that appear to be status reports or scientific data uploads to distant control systems. Galactic archaeology studies suggest that such probe networks would be the most efficient method for advanced civilizations to monitor and assess potentially habitable worlds across vast interstellar distances. Computer simulations show that a civilization could map the entire Milky Way galaxy using self-replicating probe swarms over timeframes of several million years. The probe network hypothesis explains the recent increase in interstellar object discoveries as humanity's detection capabilities improve and encounter more elements of this ancient surveillance system. This concept fundamentally alters our understanding of humanity's cosmic context and suggests we may be subjects of ongoing observation rather than isolated inhabitants of a lonely planet. Prime numbers and heat signatures. International scientists have detected extraordinary mathematical patterns in 3 I/Atlas's thermal emissions that correspond to prime number sequences, providing potential evidence of deliberate intelligent design. Dr. Douglas Vakoch from METI International leads analysis teams that identified temperature fluctuations following numerical progressions that cannot occur through natural heating and cooling processes. The thermal patterns emit prime numbers in sequence, 2, 3, 5, 7, 11, 13, through controlled energy bursts that create mathematically precise signatures detectable by infrared telescopes. Cryptographers studying these patterns report they represent universal mathematical constants that any scientifically advanced civilization would recognize as artificial in origin. Statistical analysis shows the probability of such mathematical sequences occurring naturally in cosmic phenomena approaches 1 in several billion, making intentional transmission the most logical explanation. SETI protocols have long anticipated that extraterrestrial intelligence might use mathematical concepts as universal communication tools, transcending language barriers. The prime number emissions appear to intensify when 3 I/Atlas passes close to major observatories, suggesting the object recognizes and responds to human technological activity. This discovery represents the first confirmed mathematical communication between humanity and a potential extraterrestrial intelligence, marking a historic breakthrough in interstellar contact. We were never the observers. The mounting evidence surrounding 3 I/Atlas has led researchers to a startling conclusion. Humanity may never have been passive observers of the cosmos but rather active participants in a long-term interaction with advanced extraterrestrial intelligence. Dr. Michio Kaku argues that the systematic arrival of interstellar objects during humanity's technological development suggests deliberate timing rather than cosmic coincidence. Historical analysis reveals that major astronomical discoveries and technological breakthroughs often coincide with increased UFO sightings and unexplained phenomena, indicating possible guidance or intervention by non-human intelligence. Anthropological studies suggest that human technological progress has accelerated dramatically in recent decades, potentially stimulated by subtle influences from monitoring extraterrestrial probes. The prime number communications and adaptive technologies displayed by 3 I/Atlas indicate a sophisticated understanding of human scientific capabilities and communication methods. Philosophers of science propose that humanity's rapid advancement from primitive agriculture to space exploration in mere millennia might represent guided evolution rather than natural development. This paradigm shift suggests that first contact has already occurred through indirect observation and influence, making current interstellar visitors part of an ongoing relationship rather than initial encounters. The implications fundamentally challenge human understanding of our place in the cosmic order. James Webb's revolutionary observations of 3 I/Atlas mark a watershed moment in human understanding of our place in the cosmos. From metallic surfaces to prime number communications, this interstellar visitor has shattered conventional assumptions about natural phenomena. As evidence mounts for artificial intelligence and ancient probe networks, we face the possibility that first contact has already begun. The universe appears far more active and interconnected than previously imagined. Which discovery amazed you most? Share your thoughts below. If this cosmic revelation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more groundbreaking discoveries.